All right, let's talk about special right triangles. Now, if you thought these were just some random thing from geometry class that you could forget about, well, think again. These two little shapes, they are your absolute secret weapon for precalculus, for calculus, and for pretty much everything that comes next. So let's dive in and see exactly why they're so critical.
And look, I'm not just being dramatic. Here's the deal, and this is a big one. In calculus, you're not going to have a calculator for a lot of problems. Seriously, your success will literally depend on your ability to just see these triangles in your head, instantly, to get those exact values, no decimals allowed. So that's our mission today. We're going to master these things.
Okay, so here's the plan. First, we'll talk about why these are your secret weapon. Then we'll get into the nitty-gritty of our two stars, the 45-45-90 triangle and the 30-60-90. We'll run through some examples to make it all stick, and then we'll see where they pop up in the real world. Right, so why are we calling them a secret weapon? Because honestly, this isn't just about acing your next quiz. This is about building the entire foundation for higher level math. Think about things like the unit circle or trigonometry. You know, the places where your professor wants an exact answer, like the square root of 2, not some long, messy decimal. If you master these two simple shapes right now, trust me, all that advanced stuff is going to feel so much easier down the road.
All right, let's meet our first special triangle. This is the 45-45-90. I like to call it the symmetrical one. It's super balanced, which makes it really easy to remember once you see where it comes from. So where does this thing come from? It's actually super simple. Picture a perfect square, right? All sides are equal, all corners are 90 degrees. Now, take a knife and slice it right down the diagonal, corner to corner. Boom. You've just created two identical right triangles. The original 90-degree corners you sliced through, they just got split in half, turning them into 45-degree angles. And that's how you get a 45-45-90. And because it comes from that perfect square, it makes total sense that the two legs, the two sides that aren't the diagonal, are always equal. So if we call the length of those legs x, the hypotenuse has a really simple relationship. It's just x times the square root of 2, every single time. The little memory trick here is perfect. Legs are same, hypotenuse gets root 2. Simple as that. Okay, on to our second special triangle. This one's the 30-60-90. It's not a perfect, symmetrical little guy like its cousin, but don't let that fool you. Its side lengths follow a pattern that's just as predictable and, honestly, just as useful.
So, what's its origin story? This one starts with an equilateral triangle. You know, the one where all sides and all angles are equal, so every angle is 60 degrees. Now imagine dropping a straight line, an altitude, from the very top point right down to the middle of the base. You've just split that triangle perfectly in half. That top 60-degree angle gets chopped into a 30-degree angle, and where the line hits the base, you've created a perfect 90-degree angle.
Now, here's the key to the 30-60-90. Everything revolves around the shortest leg, and that shortest leg is always opposite the smallest angle, the 30-degree one. Once you find that short leg, let's call it x, the rest is a piece of cake. The hypotenuse is simply double the short leg, so 2x, and the other leg, the long one, is the short leg times the square root of 3, or x square root 3.
Okay, let's do a quick side-by-side, a little recap. On one hand, you have the 45-45-90. It comes from a square, its ratio is simple. X, and x times the square root of 2. On the other hand, you have the 30-60-90. It's born from an equilateral triangle, and its ratio is x times the square root of 3, and 2x. Seeing them together like this really helps lock in their different patterns.
All right, enough with the theory. Let's actually put these triangles to work. We're going to walk through a couple of quick examples so you can see just how powerful these patterns are for finding missing sides. But first, a quick heads up on a super common mistake. People are always mixing up the sides of the 30-60-90 triangle. Here's the golden rule, write this down. The shortest side is always across from the smallest angle. The longest side is always across from the biggest angle. It just makes sense, right? So your short leg, x, is opposite the 30 degrees, and the hypotenuse, the longest side, is opposite the 90 degrees. Never forget that.
Okay, example number 1. We've got a 45-45-90 triangle. We know the legs are both 5 units long. The mission? Find the hypotenuse. This one's pretty straightforward. Step 1. What's the pattern for a 45-45-90? It's x root 2. Step 2. Just plug in what you know. We know the leg, x, is 5. So the hypotenuse has to be 5 times the square root of 2. That's it. We're done. The answer is 5 root 2. See how easy that is?
All right, let's ramp it up just a little bit. Example 2. This time, we've got a 30, 60, 90 triangle, but we're starting with the hypotenuse, which is 10. We have to work backwards to find the 2 legs.
Okay, listen up, because this is the most important part of solving these. You always find the short leg first. It's your home base. We know the hypotenuse is twice the short leg, right? It's 2x. So if the hypotenuse is 10, that means 2x equals 10. A little quick math, x must be 5. That's our short leg. And once you have the short leg, the rest is easy. The long leg is just the short leg times the square root of 3. So it's 5 rad 3. Done.
So at this point, you might be thinking, okay, cool patterns, but when am I actually going to use this stuff in the real world? Well, you'd be surprised. These ratios are all over the place, especially in fields like construction. Take a look at this number, 1.414. Does that ring a bell? It might just look like a random string of digits, but if you're a carpenter, this number is your best friend. Any guesses what it is? It's the square root of 2. Or at least a really close approximation. See, in construction, when they build a roof with what's called a 12-12 pitch, it means the roof goes up 12 inches for every 12 inches it goes across. What does that create? A perfect 45-45-90 triangle. So a carpenter can just take the horizontal distance, the run, multiply it by 1.414, and get the exact length they need for the angled roof rafter. It saves a ton of time and makes sure everything fits perfectly. And that's just one tiny example in construction. These triangles are literally the building blocks for the unit circle in trig, and the unit circle is used everywhere, from electrical engineering to mixing audio for your favorite songs. They build circles, they build roofs. It kind of makes you wonder, right? What else out there in our world is secretly built on these 2 simple, powerful little ratios?